Today we're going to be dealing with linear inequalities in two variables, and really, if this is page 159 of your student journal, if you think back to dealing with inequalities before, we had some different signs. We had that sign. What's that one called? Greater than. We had this guy right here called less than, and then we had the less than or, and we had the greater than or equal to. Okay, so just remember what these signs are called. That's greater or equal. And this one's less, and this one's less or equal. Now, when we're dealing with inequalities, if you recall, back when we dealt with one variable, we did, like this was an open circle. This one was a closed circle. Open circle meant it wasn't part of the solution. Closed meant it was. When you're dealing with graphing inequalities in lines, so when you have two variables, you're going to have a line. When you're dealing with this, we have a dashed line. These, the greater than and the less than, are dashed lines, whereas the equal to pieces are solid lines, just like our normal line, which is an equal. Okay? Meaning, this means my answer can lie on the line, and this means my answer cannot lie on the line. So just making a note to yourself like, hey, a solution that's on a dashed line is not a value that will be true for our inequality. A solution that is on a solid line is a value that is true for an inequality. We'll see that when we start graphing here in a minute. I'll also reference the term half planes, which we'll see, and I think that should kind of cover it. There's some info on the bottom there on how to graph if you'd like to reference that, but we're going to just try some of these problems together. I don't think this is going to be a terribly difficult thing for us, but let's give it a go. I want you to take a look at page 160. On 160 it says, tell whether the ordered pair is a solution. Okay, how do you know if something's a solution? Sarah? What's that? Oh, like in this case. Yeah, let's just plug them in. This is our x, this is our y. We just plug them in. So calculate it right now. See if that's a solution, please. Good, so we get 5 is greater than 5. True?
No.
No. This is not, because 5 is not greater than 5. It's equal to, so if it had the little equal to symbol, it would be good, but it doesn't, so it's not. Let's try number 2. Yay or nay?
Yay.
Yeah, yay. 5 minus 3 is greater than or equal to 2. In this case, 2 is greater than or equal to 2. The equal to part saved our day. That is yes-amundo. Okay. That is true. Any questions there? Let's try one more. Try number 4 for me, please. Actually, not 4. Number 6. Go to number 6. Number 6 has some amazing negative symbols. Awesome. Give number 6 a go. You know, when you're doing number 6, make sure as you substitute these in, that's a negative, x minus 2 and then y greater than or equal to 5. So when I put in x, I'm just plugging it in only for the x. So that gives me a negative 2. And this negative 3 I put in right here. So I have negative 2 times negative 3. So negative 2 is 2, or the opposite of negative 2 is another way we say that. And then negative 2 times negative 3 is 6. And what type of 6? Positive 6. So that's 2 plus 6 is greater than or equal to 5. That is true-amundo. So yes, that is a solution. It makes it true, therefore it is a solution. Oh, I'm sorry, it's 8. Whew. I just noticed that. I don't know how I noticed it. Bailey. As soon as
I'm slow on the other.
man. All right. Good thing. Try number 7. I want you to graph it. You work together with a partner there?
Y is greater than... No, Y is less.
All right. This function only has, or this equation only has a y in it. That means it's only going to cross the y-axis. Crosses at 4. Now this, if I draw it in here, what's wrong with it?
That's a solid line.
It's not solid. It is dashed. Should be a dashed line there. Okay? It doesn't have the equal to symbol, so you need that dashed line. Now, here's the deal. We've got to figure out, do we shade up here or down here? Yeah, and the way you can test that, I mean, this is pretty easy. It's less than 4. You think of all the smaller values than 4. But you can always test a point over here. So, like, if I tested this point, what's that point called? 0, 0. So if I put 0, 0, that means when y is 0, I'm at that point. So if I put 0 right here, 0 is less than 4. That is true. Therefore, I have to shade over this point I tested because it is a solution. Meaning the points on the other side of that line would not be a solution. They're not on our team, man. Okay? So like if I tested this point, what's the coordinate of that point?
That is 5, 1. No, 1, 5.
Cassie, take your earbud out. Okay? What's the coordinate of this point? Yeah?
1, 5.
1, 5. 1, 5. And what's our y in this? 5. So if I put that in, is 5 less than 4? No. So it can't be on there. In fact, if I picked a point on that line, like this point, now I'm at 1, 4. Okay? The order pair 1, 4, that's our y value. I put that in. Is 4 less than 4?
Nope.
Nope, doesn't work out. All right. It's on dashed line. Yes, Isabel? That symbol right there. If it doesn't have the equal to part, it's dashed. Yep. All right. Good. Okay. Why don't you guys try number 10? Which axis does it cross? X or Y? Or both? Yeah, just X. Is it solid or dashed? Solid. Okay. It's got that equal to part. That makes it solid. Okay. Pick a value. Huh?
Yeah, the crest of the y-axis.
Oh. Well, good. Someone caught me. No one else was going to actually say anything. Yes, I crossed the y-axis. It has to be the x-axis at -1. Hey, you guys got to stay on top of the lesson. They just earned a dum-dum, man. Dude.
They actually earned
No,
two.
it's dumb. Okay. Dumb. All right. X is less than or equal to -1. So I'm picking the values that are less than -1. If I test this point is 0, 0. Okay, I plug in my x, which is right here. 0 is less than or equal to -1. Is that true?
Mm-hmm. Oh, no.
No, 0 is not less than or equal to -1. Therefore, I do not shade over this point. I've got to shade on the other side of it. All right. Okay. Questions? All right. Well done. All right. Moving on. Next page. Try number 13. Lucky number 1, 3. Okay. Y-intercept is 1. Rise 3. Run 1. We're dealing with a line, so it is going to be a dashed line. Okay, so it doesn't have the equal to part, so it's dashed. And now you have to calculate, you can use any point. So if I wanted to use, maybe not 0, 0, if I want to use 1, 1, is 1 less than or equal to 3 times 1 plus 1?
No.
No, this is 1 less than or equal to 4. Is that true? Yeah, that is true, man. Okay, 1 is less than 4. So we have to, which side? Side A or side B? Okay, tell your neighbor, A or B, why or why not?
B.
How we say A? How we say B? That'd be right. It is B. Okay? B for like Brendan. Then again, it could be A for like Asher. Brendan Asher. Okay? It is right here. Okay? Okay, I want everyone to try number 16. Alrighty-o. How many changed its slope-intercept form? How many used XY intercepts to graph it? Dude, no one? Okay, I would use XY intercepts. You could change the slope-intercept. You go to slope-intercept, you just move the X over, and you go Y is less than or equal to X minus 3. Okay? Yeah, it would be greater than or equal to. Okay? So, you could do that. However, you also have negative 3 here. You could just say, well, if X is 0, my Y-intercept is negative 3. If Y is 0, my X-intercept is negative 3. Either way will work. If you use this form, you go to here and you go down 1 and over 1. And you get that same trend. Is it solid or open? Solid or dashed, I mean.
Dashed.
It is not dashed. It is solid. Okay? If I test 0, 0, does 0, 0 work?
Yes.
0 plus 0 is greater than negative 3. Is that true?
Yes. Oh, no. No.
It's true.
No.
It's true.
No.
Okay, pause. Everyone focus up here.
It's true.
Raise your hand for false. Raise your hand for true. That is a true statement. 0 is greater than negative 3. That means we have to shade over that point. That would mean, by the way, if I put this point in right here, would that be a solution?
Nope.
You would not make that true. Okay. Number 15. Everyone give it a go. How many finished this problem? Okay, I'm gonna subtract x over. So I'm gonna get negative y is less than negative x plus 2. Anyone else do that? Then what do you have to do with this negative? Divide by negative 1. What happens when you divide an inequality by a negative?
You also flip the sign.
Yeah, we have to flip that sign. You guys remember doing that before?
Yes.
Yes, anytime you divide by a negative, remember, flip the sign. You multiply or divide by a negative, flip the sign. So that sign changes. It goes from less than to greater than. Okay? All right. That was my point in having you do this one. Is this one solid or dashed? Dashed. That's why I kind of like the dashed ones like that. Just put the little dots and put a little dash through them. Okay? Shading above or below the line. Section A or B?
All the above.
A.
Is that true?
Yes.
That is true. Therefore, you shade over that point. All right.
So far, Bailey has 3 thumbs up.
Okay. I want you to go back to this page real quick. There is one definition on there
Okay, turn the page over that way.
that we have defined using a bunch of pictures today. This page 159. Which one of those definitions?
Graph linear inequalities.
Okay, we have graphed linear inequalities. All right? What else have we defined? We actually have a solution to a linear inequality. The solution is the graph.
Okay.
Okay? How about half planes? What's a half plane?
That.
Yeah, it's the shaded part. This line cuts your graph actually into 2 half planes, a shaded and an unshaded. Okay? So you have half planes. We call those half planes. So if you ever read that term, that's what it means.
They're not always half, though.
Yeah, well, technically a plane goes on forever, so you cut it in half. We just don't see it. It doesn't look like half. All right. Last problem you have to do is number 19 with your groupies, and then I will hand out today's assignment. Number 19. Online store sells digital cameras and cell phones. Store makes a $100 profit on the sale of each digital camera, X, $50 for each cell phone, Y. All right. Want to make at least a $300 profit from the sales of both? Right? And graph the inequality. Identify and interpret two solutions. Piece we sometimes forget. Do your best there. Okay, ladies and gentlemen, what's the rate for camera? Profit of our camera is 100. 100 per camera.
1/2.
What's the profit for a cell phone?
50.
That gives us a total profit that we want to be
At least 300.
at least 300. What symbol goes here? Greater than or equal. This is our profit, okay, for the cell phones and cameras. Okay, and we want our profit to be bigger than that much. Okay? All right, so if we have that, we end up graphing it. You can reduce this equation, otherwise it doesn't fit. What can I take out of 150 and 300?
50.
Okay, 50 is the biggest. So if we take out that, that becomes 2x. This becomes y and 6. Okay? Then if you get it in y equals form, you could go that route, or you can use intercepts, which is what I would do. I'd just say, hey, when y is 0, what's x? 3. When x is 0, what's y? 6.
I predicted it.
Okay. Is this discrete or continuous? It is continuous, or this is actually number of cameras. It would have to be discrete, but when you're graphing a range, you're setting up a boundary line. Okay, and it's going to stop right there.
You can't tie half a camera or just.
Okay, if I put 0, 0 in, does it work? Is 0 greater than 6? No. Therefore, we'd have to shade up here. We'd either have to sell bigger than 3 cameras and greater than 6 cell phones. Where could I get 3 solutions from?
Anywhere on the shaded.
Yeah, anywhere in the shaded. Pick any 3 points. That one would work. That would be 6, 7.
How about 74, 1?
That one would work.
Actually, 74,
8, 5.
6.
Any of those guys would work. You can keep going.
6.
74, 6 would work. All right. Questions? Have I interpreted those solutions?
Maybe.
Tell your neighbor the interpretation of those solutions, please. These 2.
Explanation.
Okay, someone from the back 2 rows. Tell me what the 6 means here. Huh? Yeah, this XY coordinate. Go ahead, Mercedes. Okay, 6 cameras. Okay, what's the 70? Yeah. 7 phones sold. Okay, so when you're interpreting, you are using your labels to explain what they mean. So this would be 8 cameras, 5 phones. All right. So you want to make sure, once you name them, you interpret them. Okay.